Right, so I was cut off just now due to the limitations of the video recording software over here. So generally speaking, any components follow the bathtub curve, right? So bathtub curve is given over here, right? Sure. So for any component, initially when we first roll out any design or any systems, it goes through the first period is what we call the debugging period. So in the debugging period, we aim to reduce the failure rate of the component as much as possible. So for example, think about a new car model. When they first roll out the car, you heard a lot of problems, window cannot be wind down, things like that. So we are debugging all these issues. As we debug the issues, then the failure rate of the device will drop. And then when it goes into the steady period, which is a period number 2, which is also called a useful life period, the component will go through a steady state operation, and in that case, right, the failure rate of the component is fixed throughout that lifetime. And as the component age, which is this period number 3, it is called the wear out phase or the aging phase. Then we notice that the failure rate of the component will start to increase. So this makes sense, right? If you have a car that you have driven for very long, you will actually notice that the car breakdowns more often compared to maybe 5 years ago or 6 or 7 years ago when you first bought the car. So this also applies here in power system reliability. So all these are just general concept of reliability. We have not gone into power system reliability yet. And then when we talk about failure rate, when we talk about repair rate, what are them actually? So to talk about that, then we need to introduce two terms, right? The MTTF, MTTR. What is MTTF? MTTF is the abbreviations for mean time to failure, the average time to failure. Okay, the MTTR is the mean time to repair, the average time to repair. So the average time to failure means that the time needed for the component to fail. Then when the component fail, we need one to repair the component. So MTTR will give us the time that we need on average to repair the component and bring the component back to the normal state. So MTTF and MTTR, based on what I just said just now, you might have now guessed that they are both a measurement of time. They are in hours, day, month, year, etc. So MTTF is time, and time is the inverse of frequency, right? So rate, which is rate, right? So failure rate, the inverse of failure rate will give us the MTTF, and the inverse of the repair rate will give us the MTTR, right? So remember, the key here is average. MTTF is the average time, and TTR is the average time. Therefore, the failure rate lambda and the repair rate mu is also the average failure rate and the average repair rate. So if we combine MTTF and MTTR together for a particular component, then you will notice that the component goes through several cycles, right? Down, up, down. Therefore, we also call these up-down cycles of components. So the summations of the uptime and the downtime of the component give us one period of the component operations. Okay, T. So this is just to illustrate to you the cycles that component goes through if we take into account MTTF and MTTR. So as I mentioned just now over here, the MTTF and MTTR sum up will give us the period of the component operation. Yep. So the inverse of the period will give us a frequency of the event occurring. Yeah. So we can also define availability and unavailability in this sense. Just for your information, right? Just for sharing. So availability is the probability of the component in the uptime. We call it availability. Unavailability is the probability of the component in the downtime. We call it unavailability. So based on my definitions, availability is the probability in the uptime. So the uptime just now we know that is MTTF, right? MTTF is the time to failure. So that so MTTF also describes the amount of time that the component is in the uptime. And then you want to